Okay, the height of the tree, so the height of the tree in meters, can also be modeled by a function g they did something tricky here. Notice this is not g of t. It's g of x. Whereas the previous function they talked about was h of t. So a little on guard for that. Where x is the diameter of the base of the tree in meters. So they're created a function here where you have the height g, and that height changes depending on the base diameter. So you have the base diameter that's x, and then we have the height, which they have assigned the symbol g of x. Interesting function. The input is in meters, and the output is also in meters. This is the last problem on the first question, but I definitely, so that's good news. So hopefully I've done everything else first. This already feels, I'm just a little on guard here. When the tree is 50 meters tall, so at some point g of x, we don't know the x, so let's do it this way. So somehow g at some point, we'll just say g of a, the height of the tree is going to be 50. The diameter of the base of the tree is increasing at a rate of 0.03 meters per year. Okay, x in this case is the diameter. So what they just said was, at some point when the height is 50 meters, the base of the tree is increasing at this rate. So that means dx dt, because x represents the base diameter. 0.03. This is exactly what you should expect for the AP test. They always come up with something that's just different than you've ever seen before. So you just keep reading. According to this model, what is the rate of change in the height of the tree with respect to time? Ouch. Because they gave us this formula g, but g is a function of x. They don't want the rate of change of g with respect to x. They want the rate of change of g with respect to time. So they want somehow to find the change in the height with respect to the change in time. At the time when the tree is 50 meters tall. So whatever that moment is when the height is 50. Well, my only thought is, I have this formula, another good example of don't let yourself get stuck. You've done everything else. You still have time, do what you can, but I have this formula. My only thought is, if I take the derivative with respect to time, so I'm going to take d of g with respect to time and see what happens here. That's the quotient rule, so it's the bottom multiplied by the derivative of the top, d of 100x over dt. This feels really weird. Change color here. Minus the top, 100x, times the derivative of the bottom. So that'd be d of 1 plus x over dx. And then the whole thing is divided by bottom squared. So that's 1 plus x all squared. X represents the diameter of the tree. Yeah, really tricky problem. They gave me 2 points for this part here. So it was wise to, even though it felt uncomfortable, to say, okay, don't really remember doing a derivative like this, but I'm following the rules. So that was logical at least. That was worth 2 points. The part of the problem that I did not notice until I looked at the scoring guide, so I would not have earned this point, is when they told me the height of the tree at some diameter of the tree is 50, I could have used that information to go find the diameter at that moment. So I would have done this. I'd say, okay, 100x divided by 1 plus x, that's the height of the tree. That height is 50. And from that, I can solve for x. Because I can have 100x, multiply the denominator across, like this. Then you have 100x equals 50 plus 50x. Subtract the 50x across, you end up with 50x equals 50. Therefore, the diameter of the tree is 1 when the height of the tree, g of 1 is 50, sorry. So the moment that I'm interested in, that the question is asking about, is this moment when the height is 50, and therefore the diameter is 1. So using that down here, I could plug those into this equation, because here I plug in a 1. I'd have to finish a little bit more, so let's copy this over here. Grab the eraser. Okay, so what I'm going to do is take this formula here. So I'm going to have the change in the height with respect to time is going to equal 1 plus x. Then right here, the 100 is a constant, a multiplying constant. So that becomes 100 dx over dt. And I know dx over dt because it told me right here. The diameter of the tree is increasing at a rate of 0.03 meters per year. So that's minus. Let's get rid of this. Now we're here. We're actually over here, this portion. So we have 100x. And then this derivative here, I'm going to have d1 over dt, which will be 0, and then dx over dt. So this is dx over dt. And all of that is divided by 1 plus x squared. So what I'm looking for is dg of x over dt. Trying to find that. One more time. dg of x over dt. Trying to find that when time is equal to, not time x. This is a very different problem. when the x value is 1. So that's going to equal, you just plug everything in, 1 plus the x value multiplied by 100. The x dt is 0.03. I'm not going to have to work anything out, so that's good news. Minus, parenthesis, 100 times 1, close parenthesis, another dx dt, 0.03. And then all of it gets divided by 1 plus 1 squared. And I get one more point for that. That's very common on the AP test. The first two of the 3 points came fairly quickly. It's getting that last point that takes a long time. Therefore, again, don't let yourself get stuck. The moment it feels confusing, unfamiliar, if you get stuck, just move on. Then you come back and try and get those extra points later, because you do not have to get all